Assalamualaikum warahmatullahi wabarakatuh. My name is Norizatihusna bin Wahab. In this video, I will present about water reticulation design that has been done by my group for our hydraulic project. This is our members. I am Norizatihusna and my group member is Norinsyirah Basir, Maizatulakmar, Batrisyia Halmi and Safiyyah Aisyah. These are the purpose layout that have been given to us to complete this project. The material that we use in this project is ductile iron pipe, which has diameter of 0.2 meter and Hazen-Williams coefficient C is equal to 110. And this is pipe length for each pipe in our project. Firstly, we have to determine the water demand calculation. In this project, the total water demand that we calculated is equal to 407,311 LPD. This total water demand we got from the submission of water demand at Block A to Block H, water demand cafeteria and water demand at main building. Next, we calculate the peak flow and firefighting flow. To calculate firefighting and peak flow, we have to determine the water demand for each node in this diagram and this diagram to multiply with 2.5 and multiply with fire risk. By the way, before we calculate the firefighting flow, we have to determine the class type of the building. In this project, the class type building that we have is equal to B. We have maximum number of hydrant and equal to 2. Next, we determine the head balance method calculation. This is our HPM table. We have to determine the delta H and delta Q is equal to 0. So after 7 iteration, we got the delta H and delta Q is equal to 0. Next, we have to determine the residual head. In this calculation, we use the formula to determine the residual head. If you guys notice, at this node there are OK and not OK residual head. The OK residual head is more than or equal to 0.6, but the not OK residual head is less than 0.6 meter. So for not OK residual head, we have to increase the pipe size to reduce the losses. The last step is to design water tank reservoir. In this step, we have to determine the minimum capacity and maximum capacity of our tank. This is detailed for our RC service tank and RC suction tank, which you guys can see the H elevator, the H and the radius, diameter, the volume and H again. Oh no, this is volume. And this is our RC service tank diagram that we conducted at AutoCAD. And this is our RC suction tank diagram that also be drawing at AutoCAD. That's all from me. Thank you for watching.